Hello, I'm Paul Beckwith, and I'm at Crawford Lake in Ontario. It's about, half an hour north of the Lake Ontario, in Milton. So it's north of Oakville, sort of Burlington area. And it's been in the news. It's been in international world news over the last several days. And there's a very good reason for that. It's considered possibly the golden spike of the Anthropocene. So I'll explain what's meant by that. So this lake has very, very unusual properties, unusual characteristics in that it's meromictic, okay, which means that the upper part of the lake and the lower part of the lake don't mix. So the water depth has been reported at mostly about 22 meters, but I've heard, some people say 25 meters. It's a small enclosed lake. It's probably spring fed because it's very unusual for a meromictic lake in that there's supposedly oxygen in the bottom layer. Most of these type of lakes have no vertical mixing, so there's no turnover of the lake twice a year in the spring and fall, like with most other lakes. And that's because the water density is highest at 4 degrees Celsius. So when you have a freshwater lake, and you go into the winter, the water gets colder and colder and colder at the surface because the air temperature is well below zero. So the water cools down until it reaches 4 degrees Celsius, and that's the temperature at which fresh water is the densest. So then that 4-degree water sinks, and it's replaced by warmer water at the surface, which then cools to 4, and that sinks. So eventually, in lakes of reasonable depth, the whole water column becomes 4 degrees Celsius. And then when you get colder than that, the water is lighter and stays at the surface until it goes to below zero and freezes. And then you get your ice layer on the surface of the lake. Okay, so that's a very sort of unique property of water. So what would normally happen in a lake like this would be, the water gets to 4 degrees, then you get your ice, it cools even more at the surface, you get your ice layer, and it's 4 degrees all the way down to the bottom. And because surface water can go down to the bottom, it carries oxygen, and you get the mixing of the lake, and you get nutrients coming up from the bottom. But I think what happens here is, it's not 100% clear to me. Okay, come on. Okay, Newton, come. If there's a jerking of the camera, it's because my dog has seen a squirrel or a rabbit or something, and I have to pull like crazy at the end of the leash. Okay, so what happens here is, because there's no mixing, normally you'd have no oxygen in the bottom layer of the lake, the deepest layer. But in this particular case, there's oxygen at the bottom, so the oxygen's probably getting in from the water that's coming into the lake. It's spring fed. There's probably oxygenated water in the spring fed water, which is coming up, which gives oxygen to the bottom. I don't see any other way it can get down there because there's no overturning of this lake. So why isn't there any overturning? Well, obviously the 4 degree C water that is sinking must actually reach water near the bottom that is denser, so it doesn't descend any deeper. So I'm guessing that might be at about the 15-meter level. No boaters, no swimmers, no canoeists. Nobody's been allowed in this lake since the 70s. I heard there was police were here at one point. Police divers were going down to the bottom.
Hi.
Hello.
Hi.
So lots of people on the trail. Yeah, so police divers went down, and it looked like they reached the bottom at about 15 meters, but kept going down and sort of pushed through a layer. So it was a layer heavily laden with sediment, different color, like you might call it a false bottom. And I've heard of this situation. So what I'm guessing is that whatever solids were suspended in solution, just sort of weightless there in that bottom layer, made that water denser. So that water was denser than the 4 degrees Celsius water, fresh water, which was descending, and it kind of like stopped there and didn't go down the rest of the way. That's a bit of that's my hypothesis anyway, a bit of a speculation. Okay, so what makes this lake fascinating is that sediment cores were first taken in the lake many years ago, decades ago, and it was found that the lake is heavily varved. So what that means is that in the sediments there's light mud. So basically you get sediment in the water. Anything going into the surface of the water then starts to sink through the water very slowly and builds up on the bottom, building up sediment layers. So in the winters that layer is light muds, light sediments. But in the summer, there's a period of time when you get white material settling, and that's calcium carbonates. And so how does that get in the water in summers? And it's been varved like that for 1,000 years. So you can just count the varves, count the light, dark layers in the sediment core that you take from the bottom, and you can get a lot of information about the history over the last 1,000 years. Well, first of all, how was the lake formed? It's believed that the lake is about 10,000 years old. It's believed that the lake, that it's limestone in the area. It was believed that the limestone basically eroded away, right? It's soluble in water. So a big cave basically formed. And then during the ice age, there was several kilometers of ice on top of this whole region, and that would apply great pressure, and basically the top of the cave system collapsed, opening it up. So it was basically a lake. As the ice retreated, it was a lake. And like I said, it's spring fed. There's no rivers bringing stuff in. There's also runoff from the land. But it must be that the springs come in at the very bottom and provide the oxygen, like I said. So going back the last 1,000 years, at least, there's varved, very heavily varved sediment. So alternating bands of light, dark, light, dark, light, dark. And so we can count the layers back and know what year it is. And we can find out what's in the mud, the pollen, etc., from the trees in the region, to find out what the vegetation was like around the lake for the last 1,000 years. We can look at isotopes to determine the mean annual temperature, and the hottest temperature, mean July temperature, I guess. Do things like that. Also, from the pollen distribution, we can determine the mix of vegetation, and that in turn gives us, along with mean annual temperature, it gives us things like mean annual precipitation in the region over time. So we can see things like the Little Ice Age. We can see an increase in dust, etc., from World War I, World War II, the Dust Bowl, any volcanoes that have gone off in the last 1,000 years. There's a record in the sediment. We can see the nuclear testing, the open air nuclear testing, plutonium and other radioisotopes are in the sediment cores. The sediment core, we can date them. Remember, we can date all of this stuff just by counting the layers. I mean, there's other ways to date, but we just count the layers, and each layer, we have resolution down to a single year, basically. So the International Union of Geologists, they've been bickering back and forth about having a new term called the Anthropocene to describe the situation today, and they haven't been able to agree on how we should actually define the Anthropocene. But the consensus was, there was an announcement just a couple of days ago that this lake is very likely going to be the marker for what was the Anthropocene, and the date, they're saying 1952, because after 1952, and that's when, of course, the plutonium and other radioactive elements are detected in the sediments from the open air nuclear testing. But after 1952, it's what we call the Great Acceleration. Huge acceleration in population, huge acceleration in industrialization, and pollutants going into the atmosphere, levels of gases changing in the atmosphere, all of these different things. So it's not 100% that they're going to use this lake. What they call it is the golden spike, if you like. The golden spike idea is, okay, you peg it at 1952, and this lake is a record, of us entering the so-called Anthropocene. Anyway, so what that has done, what that announcement just a few days has done is it's put this lake on the world map. So there's been, I talked to some of the people working here at the conservation area, Crawford Lake conservation area, and they've had media interviews from just about everywhere. So on my way walking here, I spoke to a British couple and said, hey, by the way, this lake is headlines on the BBC. Did you know that? And of course they didn't, so that was quite interesting. But Reuters, I read an article in the Washington Post about it, the New York Times, all the Canadian newspapers, radio reports, CBC, everything. This is a place. This is Crawford Lake. Some of the headline media across the world shows a satellite image or a drone image from above the lake, and see this little lake nestled among the trees. It's sort of the lowest. It's sort of, you have to go down, and then the lake's down below. It's sort of sheltered from winds, which is very important because that reduces the amount of mixing of the water column. It means that there's not much wind. It's pretty much undisturbed. Like I said, people haven't canoed or boated or swum in the lake since the 70s. It's been in a protected area, so it's been and what's interesting is, so some of the information they've got from these varves in the lake, it's like a time capsule or a time machine, if you like. But they found grains of, I think it was 1200s, 1300s, 1400s. They found grains of corn, pollen from corn, pollen from squash. So they determined that there was some farming of those things back at that time. So that was indigenous farming. And then they investigated the area, and they found signs of longhouses. So there was First Nation settlements right in this area, fairly close to the lake. Of course, when the Europeans came a couple hundred years ago, 200-300 years ago, they cut down a lot of trees and started, having different types of industrial processes. There's signs of all that in the lake too. So this is interesting. Meet the Crawfords. The concrete structure in the background there was the front porch of a cottage owned by the Crawford family. They bought this land in the late 1800s, built a lumber mill at the south end of the lake, later used the area as a summer retreat. In '69, concern for the preservation of the lake led the Crawfords to sell the land to the conservation Halton area. So you can see there's interesting images of the Crawfords, and they called it was Little Lake, okay, but basically became changed to Crawford Lake. And there's old pictures there. Okay, so there's some interesting history there on that plaque. Newton's behaving well so far. Crawford Lake's first settlers, the Iroquoians. Evidence suggests that Iroquoian people lived in the Crawford Lake area from the 1300s until the 1600s. Okay, so First Nations used the lake as a source of food and water. Archaeologists began their search for the settlement by questioning nearby property owners. There were artifacts found in fields, etc. By 1987, more than 10,000 artifacts and the remains of 10 longhouses had been discovered. Thousands of sunflower seeds, shell fragments were found in lake sediment dating from 1270 to 1670. So it suggested that people separated the shells from the seeds and oil by grinding them on a rock, placing them in the water, allowing the shells to sink, and the seeds and oil to float to the surface to be collected. Okay, so there's also, as I mentioned, the pollen for corn and also pollen for squash in the lake. So there's distinct layers in the sediment core of the mud in this lake showing the presence of First Nations people all around the lake between 1270 and 1670. Okay, come on, Newton, come on. So I was visiting my mom in Oakville. That's been planned for a while, and the timing is because my son's at Trent University in Peterborough, so he visited us in Ottawa on the weekend and needed a ride back. So usually when I drop him off in Peterborough, I head on to Oakville to see my mother. And of course, this lake has been in the news. I'm sure I was here when I was a kid. I don't remember it. When I learned to scuba dive in grade 10, I know I did my open water diving in a quarry very close to here called Gulliver's Lake. I'll have to look it up. Here we are at the beginning. Okay, so it's taken 20 minutes to walk around the lake and talk about the varves and talk about the history and talk about all the excitement in the news about this lake in the last few days. The probable location of the so-called golden spike, which demarcates the difference or the separation from the Holocene, which we've just left, to the Anthropocene, which we entered in 1952. Normally you have to look in the rearview mirror to see, when you have these transitions. This lake looks exactly like Pink Lake in Gatineau, and there's no oxygen. It's a merrimactic lake. It's a great hike. It's about the same size as this lake, but there's no oxygen at the bottom of that lake. I don't know if it's spring fed or just fed from water drain off from the land. No rivers or streams going into it, but it's also a protected lake, in the Gatineau Park Conservation Area. Yeah, so anyway, thank you for listening. Fascinating place. I'm glad I came out here. Gorgeous day. Newton needed a walk. I'm surprised they actually allow dogs on the path all the way around the lake, but I think they've been doing that for many years, and it didn't seem to mess up the sediments. Find dog poo maybe it's dog poo in the dark layers of the sediments. They're mistaken. I guess one question is how does the calcium why is there calcium deposited in the lake in quantity to give these white layers and the varves? And I thought it was phytoplankton growth in the summer. Warmer water at the surface, nutrients running in from the land, phytoplankton growth. And some of the phytoplankton has a calcium carbonate or aragonite backbone, and as the plankton died and settled to the bottom, it would deposit that calcium on the bottom. Okay, that was what I thought, but then I read in some of the articles that it was the rock around the edge of the lake, kind of sheds some of the small particles and calcium, and it gets into the lake. I guess it would be washed into the lake from intense rainfall or something in the summers, and then settle into the bottom, giving these varves. So I'm not really sure, actually, now. I mean, I was pretty sure it was the phytoplankton, but the articles, I've read a couple articles, like I said, that say it was flakes of rock around the edge that provided the source of the calcium carbonate in the summers to make. Anyway, the lake's been varved for about 1,000 years, and I'm not sure also if if the sediment thickness, how thick the actual sediment is, like what's underneath. I mean, what's limiting it to 1,000 years? Why can't you go back 5,000 years, 10,000 years, right? And are you at the bedrock or the limestone? I mean, the sediments are only so thick, or are you? I'm not sure. Actually, if it's anything, I'm thinking of Mer Bleu in Ottawa. So I went on a couple trips where we cored that lake, and the core goes through the peat and so on, and then it hits sand, and you can't penetrate through the sand layers, and the sand was deposited there when the area was inundated with salt water. So the ice melted. There was a huge marine incursion. Sea levels were much different. The land, the land height from isostatic rebound was different. So there was an inland, marine incursion, and it deposited the sand, and that was sort of the limit. You couldn't do the coring through that sand. So maybe that's the same sort of situation here. Although the sand was deposited much longer ago, many thousands of years ago. So I don't know. I don't know. There's a lot of questions, and I'm not saying that nobody knows, but I only had a couple days to do some research on this lake, and also, I do remember. I'm pretty sure I have a video. If you go back a number of years, I have a video where I walked around Pink Lake, the Merrimack Lake in Gatineau, and discussed similar things to do with that lake. So anyway, it's a very fascinating place, and huge numbers of visitors here, but most of them aren't aware of the media frenzy in the last couple of days. They just it's part of their summer camps or trips to the lake. So anyway, yeah, thanks for listening, and Paul Beckwith reporting from Crawford Lake, the location of the golden spike separating the Holocene from the Anthropocene in 1952 is the year they've designated. Okay, bye for now.